All right, we're going to look at 16.5, which is going to be strong acids and strong bases. We've already done this before. We did this on chapter 4. Okay, strong acids are the HCl, the HBr, HI, and then you have H2SO4, HNO3, HClO4, and HClO3. So those are the 7 strong acids that we've already looked at. Remember, we've talked about that these are reactions that lie almost entirely to the right. These are where my acid is the only source of the H plus ions. Okay. And at equilibrium, almost all of your original acid is now in the form of ions. So like we talked about, they lie to the right, which means they totally dissociate. All right, if you have a strong base, on the other hand, okay, strong bases are the same thing we talked about before. Okay, they're the Na, Li, K, Rb, Cs. Then you have barium, strontium, and calcium. Okay, the only contribution of your ions is from your base that we care about, which is usually the OH minus. Okay. And your base completely dissociates into its 2. You just got to be careful for some of these later on with the ones that fall apart into 2 things of OH, because that will change our pH and our pOH. All right, so we're going to find the pH of a 0.04 molar solution of HClO4, and we're going to do the pH of a 0.02 molar solution of NaOH. These ones are easy because this right here is a strong acid. Since it's a strong acid, we're dealing with the only way we get our pH, okay, is that hydrogen is from the initial one. So all of that 0.04 molar for the HClO4 is just the H plus, okay? And so all I gotta do is a negative log of 0.04. Just pull it down and pull. I think that one might, no, never mind. Okay. One of them does that. I was like, no, there's no difference. Do you want your test tube brush too?
Oh yeah, are they up there?
They should be up there, yeah.
Wait, is this right? Oh, there's gonna be another one.
Yep. Yeah. That's fine, you can do it. Okay, so your pH should be a 1.4. So we're going to do what is the pH of a 0.028 molar solution of NaOH. Okay, then that means we're going to look at the OH minus. It's a strong base, so it completely dissociates. So I don't really care about the Na. So all of that 0.028 molar for the NaOH is now just OH minus. So I'm just going to do the negative log of 0.028. And that's going to give me 1.55. But that number is my pOH. I want a pH. Well, the 2 together add to 14. So I know 14 minus 1.55 should be 12.45. It should be a large pH because that is a base. You should not have a low pH. Okay, I want you to go ahead and try the last one for what is the pH of a 0.0011 molar solution of calcium hydroxide. Just watch out because, like it's written right here, this has 2, so there's twice as much hydroxide. Okay, so what you should have done for this one is that you should have 2 times the 0.0011, because that's going to be twice the amount of hydroxide ions, and then I do the negative log again, and then 14 minus, and you should have 11.34 as your pH for that solution.